So, I don't know whether I can see myself. I can see myself. Good. So we'll be talking about Elixir and Livebook, and it will be a terrible introduction to what I believe is a great technology. Right, so something about myself, just a quick introduction. I know they introduced me, but just a bit more about myself. Like, okay, my name is Jian Zhen. Most people call me Jay-Z because they keep calling me Jian or like Jian Zhen or something. So Jay-Z. I've been playing with code since 2013, so I was like around 13 years old, and I just really like discovering new and old technology alike, right? So, and also like just out of curiosity, I've been like the astronomy correspondent for CNA for a while, so that's like about a bit about me. Okay, so a bit of expectation setting for today. So I'm assuming that you have basic programming language and also just worked with Jupyter Notebooks before, because you will know that why this technology will actually be so interesting to you, right? So about today, a little introduction about the introduction. So what is Elixir, right? So Elixir is a dynamic language that's functional. So there are technically three paradigms to programming. So there's the functional, there is the OOP, and the last one I cannot remember. But it's called structural, if I'm not wrong. The last one is because it's built into all programming language currently, so we don't really look into it. So technically, we only have two, OOP and functional programming, right? So if you come from a very object-oriented background, everything is done in objects, which everything is a model who has properties and which will have like methods. But in functional programming, what we think of is we think of everything as data, and we'll pass data and use different methods to transform those data into what we want in the end, right? So Elixir is a functional programming language that's built on top of Erlang, which is an ancient programming language built by Exxon in the 1990s to solve their very big problem of not being able to handle the load of what they were doing back then, right? So one of the biggest Erlang apps right now is actually WhatsApp, which handles over 2 billion requests daily. So that's something that's quite interesting to you. So if you're trying to build something that handles like insane amount of like data, Erlang would be something that's interesting to you, right? So Erlang is used to build like insanely massive scalable real-time software that requires high availability. And so a little bit about like functional programming before I jump into like how I use this. Okay, so a bit of functional programming language is that instead of writing code that represents data, we write code that transforms data. So data will go into one function, another function, and go into the output. So this can come as a form of like data can be a URL that comes into a function that processes the URL into something else that turns into a web page that functions out and eventually becomes an output of a web page that is delivered to your screen. Right, so I'm gonna jump out and go to the Livebook itself. Actually, can I get the two like Ambrose and Terence? I don't know whether you guys are there to like join my thingy. I sent you guys the link.
Oh yes, I can join it.
Yes. Can you join my link? So a little bit about like this entire thing called this entire thing where we're looking at it's called Livebook, right? So Livebook is basically this like, oh my god, is it F12 or F11 to like escape out of full screen? I can't remember how to get out of full screen. So I'm just like stuck with this. Okay. So a little bit about like Livebook is that Livebook is actually a little thing that is built for Elixir data science. Right. So Elixir, like earlier last year, they believe the founder, which is Jose Valim, he himself told the world that Elixir as a language is fully complete, like it's feature complete. So there will be no new changes, like no new paradigm changes in like how the languages is designed, or as far as he knows lah, which is like, you know, like Python had a huge shift from like 2.0 to 3.0 where it broke almost everything. So according to him, he doesn't want something like this to happen. He wants that Elixir is more or less a complete language. So I'll go down line by line, right? So like Elixir is like a very functional programming language built on top of like so it's been successfully used in web development, which uses the Phoenix framework. This is actually a giant Phoenix page, by the way. Embedded software, data ingestion, and multimedia processing. So Discord, Pinterest, and Pepsi are one of the few like companies using Elixir like on what large scale. So Discord for the longest time has been like the one of the biggest like advocates for Elixir as a language because they really use it to like do real-time software really well. Right, so how do I, yeah, so like this, if you guys have played with like Jupyter Notebooks, this will be very familiar to you guys because this is basically just the Jupyter Notebooks, but much prettier. But also, right, so when I prepared this presentation, so Livebook is such a new technology. When I prepared this presentation, they were still having the initial discussion to whether Livebook will ever support Python. So back then, I was crossing my fingers that it might support Python. But like around 2-3 days ago, they basically came back and said they decided that like this entire system that relies a lot on like functional programming languages will not support Python because Python is inherently not like type safe, not there's a lot of reasons why. They gave a whole list of reasons why they will never support Python, which I'm like, okay, cool, which means if you guys ever want to use this very, very nice thing, it will only ever be used in Elixir. So yeah, in OOP we use models as metaphors and analogies. In functional programming, you take data and endlessly transform it into what we want, right? So this is a quick example. So yeah. How do I get the evaluation to start again? Type operator. Okay, so give me a name. Ambrose. Right. So if I were to like take Ambrose, and it will just return Ambrose, right? Right. So if I were to type it in, right? So this is the type operator, right? So something in functional programming language we use a lot is still typing, right? So we can do a string dot trim. So actually, you know what? String dot trim only makes sense if I have like a lot of like trim, right? Right. So it still be Ambrose, right? Then I can give it another string dot is it upcase? Upcase. Right. Then we can type. We can keep typing this. We can keep typing this, and then we can go to like string dot downcase. I think you get the idea of like how this entire like functional programming language works. It's basically you can pipe a data from one function to another function to another function to eventually get to what you want. So this is just a very, very simplified like idea of what we are doing. Another great thing about like Elixir is immutability, right? It's inherently immutable, where the thing, so immutability in Elixir is very, very weird. Immutability in most other languages means that you literally can never change the variable once it's set. But that's not what it means in Elixir. You can reassign a variable, but it just means the data is safe in transition, right? So when it's moving from one point to another point, it's safe, right? So, okay, then the next thing we'll be talking about will be Jetz, right? So Jetz is this library that Google developed. A lot of people are speculating whether it's going to replace TensorFlow or not. I don't think so, but you know, but basically, like when you look into the Jetz documentation, it's over here. So if you look in the Jetz documentation, can I like get out of like full screen? How do I get in the full screen mode? Okay, there you go. So if you look at Jetz, right? Ah, crap! I don't know how to exit this. Get back. So if you look at Jetz, right? If you look at the Jetz documentation, it does actually talk a lot about like how it's like oh, by the way, TensorFlow and Jetz are like doing very, very similar thing, but Jetz is an experimental platform trying to use the GPU and TPU more to do like very, very like specific like calculations, right? And what Jetz really does very well in Python is they tried really hard to use Python to become a functional programming language, to which Jose Valim and a few other people came together and just took a look at it and was like, we can do this in the actual functional programming language, right? So they tried. So that's where Exxon started, right? Exxon as a project started from there because they realized that, hey, we can actually use the entire XLA and autograph to like create this new thing, right? So yeah, I just realized I'm like talking in circles. I feel like I should like start talking about like how it actually is. So why we talk about Jetz, right? Jetz plays around in pure function, right? So like they really try to make Python very functional. So if you look at how they do it, it's really just passing it into like they're trying to make it immutable as well, which is like you cannot like reassign it properly, like item assignment. Okay, so Ambrose, are you in the connected users? Can you join me? Can you join me? I just want to show one last thing. That's all. So one thing that makes Livebook so fascinating to me is that it's just how Livebook was implemented. There was a lot of pain points that like they decided to like kill off and when they were designing Livebook, such as like if you were to open up Livebook, right? So if I were to go onto my thing and I were to open up Livebook itself, like where is it? This is the Livebook itself, right? If I were to open this, it's actually just in normal markdown, right? You actually can view this. Like if you were to open a normal like Jupyter file, you will never be able to look through it like this, right? You will never be able to like look at what we just typed like this. So it's pretty cool, like to me. So that's one thing. And also the other thing is it's because it's literally supported in text, right? You can actually have a Git. You can actually use Git to like do proper version control. Change your name, eh? Change your name. Can change your name. Come. Yay, okay, come. Can you click on this? Let's type something together. You type something. How about you type something? Can you type something? Yes. Really honestly very, very cool that like data science can be done this way, which is a very like by the way, if you're wondering, this is localhost. So we are doing all of this in localhost. So all of this is in localhost, and this is localhost collaboration, which is pretty cool and like something that I don't think Jupyter will ever be able to catch up to. But yeah, there are ways to do it in like Jupyter Notebooks and Python. I feel I'm just making this entire presentation about like why this is better than Python, which is not the point. The point is like you should be able to like appreciate that another technology and other technology exists for like data science as well. It's not just a Python world, right? So a little project. Let's go to do a very, very simple project. Hey, like, okay, gonna do something. Let's pipe it something. Pipe it in, pipe it in, pipe it in. I think there's a enum.split, but okay, you just do upcase, just upcase everything. Yay. Control enter. Yay. So he can be typing the entire thing and yeah. So let's do the most simple project in like data science, right? Which is the MNIST data set, right? This is like the hello world of the machine learning world. If you ever take a AI class ever before, this is actually the first thing they tell you to do. I remember this when I was doing it in my school. So we're gonna walk through doing this in here. By the way, like since like Exxon is actually designed to do like gradient calculation faster, so it's actually not a very good presentation to like show this, but I just realized that if I were to go deeper into what the Exxon is actually really, really good at, it will be a much more complex like topic to talk about. So first look into this neural network is that we'll look into like how this data set is, right? It's basically a bunch of like handwritten characters from 0 to 9. And I cannot remember how many there is, but I think there's over 60,000 training images plus another 10,000 test images, right? So it was assembled by the National Institute of Standards and Technology, NIST, or in the MNIST in the 1980s, and basically everyone has been using this as a hello world for like AI, right? So if you want to like really look into how this works, there's a YouTube video. By the way, this entire Git repo is online. I'll send it to Ambrose later on, or somewhere. I'll send it in the chat later, okay? So because of how like the entire setting up of the entire, what's it called? Livebook requires to set up Elixir, and I know that's actually a pain for Windows users. It actually is super easy for like Mac users, but it's insanely a pain for like Windows users. So I created an entire like README to set it up. So one pain point that a lot of like data science for Python especially is really like versioning your libraries, right? So how Livebook decided to do, how like Elixir decided to do is that instead of actually just doing it in a requirements.txt file, it actually live installs every single time when it installs the packages that you says you want directly in here. So we'll literally go to GitHub and fetch the libraries that you need. That is like to me like it's a better compromise than actually just like assuming everyone is going to have the exact same environment as you are, right? So run this. It will take a while to run. Actually going to download things. So yeah, oh, it's done. So yeah, so like once it's downloaded, so actually, you know what? I can restart the entire session. Wait, let me just, how do I restart the entire session? Ah, never mind, it's fine. So a bit of into like numerical Elixir, which is basically the NumPy of Elixir world. It's essentially, yeah, exactly what I said, just NumPy of Elixir world, right? So if you've seen NumPy before, you'll be familiar with this. I think one of the design goals of like NX and the design goals of Exxon was to make it as similar as possible to the rest of the data science world, so that like it's not that difficult to like transition, right? So another thing we'll be doing is we'll be transforming the data that we have, which is the MNIST data set. This data set, we're going to transform it. We're going to transform it into something usable. So we'll be doing it to like typing it. Like if you guys are really, really interested of like how this does, like, I mean, the English is there, but if you're not from a data science background, it's very, very hard to like go through it today. But you know, like, so what we're doing is firstly, we're going through the library, we're going to reshape it into like a proper shape that we want. We're going to divide it and we're going to batch it up. Right, for the labels, we're going to do the exact same thing. But so this is the images, this is the labels. Okay, moving on. Cool. So then finally, we're going to like do a proper download. Okay, cool, it's evaluating. Yay, cool. I think this is a 5. Is this a 5? Ambrose, is this a 5?
I think so.
I think it's a 5.
I can't tell.
I can't tell, right? Because there's the lines across it, right? So to design the model, the data science model for this, right? It's actually just pretty similar. If you guys come from like a TensorFlow background, this syntax is very, very similar. Because like when I started learning like Exxon, this felt like I'm home, because like it's exactly the same except for like using symbols or atoms. In Elixir we call it atoms, in Ruby we call it symbols, right? So yeah, so if you run this, this will give us the model data, which is like the input, then goes into a dense layer, go into a ReLU, then go into another dropout layer of like 0.5. I don't think I specified the dropout amount. Dense layer again, and then a softmax, because we are comparing between 10 different objects, so we're doing a softmax. So do I need to explain how softmax works? So softmax basically like goes through the different like layers and like try to calculate which one is the highest, then they just select the one with the highest amount. So yeah, so our network is now would consist of 2 dense layer and a dropout layer in between, which is 2 densely connected, which means fully connected neural network layers. The third and the final layer is a 10-way softmax layer, which just means that it's a 10-layer probability score summing up to 1, so 0 to 1, right? So each score will be the probability of the current digit that belongs to the 10-digit class. So let's say this thing, it looks a bit like 3, it looks a bit like 5, so it'll give it a probability of like, when it's 3, right, it'll give it a probability around like 0 to like 4. Like if it's a 5, it goes to 0 and 8, so you'll just select that 0 and 8, right? So once we are ready for this, we'll pick the loss function. We'll pick a loss function, right? Which is usually for this will be cross entropy. So like an optimizer will be the Adam W optimizer, and then the metric. We want to optimize for accuracy, right? So then we can just model, we pipe it into this entire thing, then we pipe it into the training, then we run it, right? Anyways, we're just actually seriously watching a computer do math. Very, very slow because my computer is 5 years old. How's life, everybody? I've never been to like a presentation where the entire crowd is so silent. So it's terrifying to me that the crowd is silent. Huh? Really? Oh my god. So they can hear me, but I can't hear them. Okay, so technically at Epoch 2, they're already at 90% like accuracy, so just training it. Very slow. You can plug it into like so for Elixir, right, you can actually plug it into many different runtimes. So it can be a standalone runtime, it can be a mixed runtime, it can be embedded to a machine somewhere, or it can be attached to a cloud server, right? So there's a lot of fun goodies, like there's even like stuff that you can like run around. Stuff you can never do in, again, Jupyter. I'm just shitting on Jupyter right now, I feel like. I'm sorry. This is actually just a new technology, so I mean, of course it has to be better, right? Run, finish, faster, faster. Very slow. Can I say that? I'm almost done. There's almost nothing else. What's happening? What's happening? Okay, so anyways, I'm just waiting for it to like just give me the okay. Faster, give me the okay. Still evaluating. Give me the time that evaluated. Yeah, so it finally finished evaluating, so it does give me like the entire like what it did, which so 10 epochs lost. And I'm not gonna decipher this, but you know you can hover over this and see like how long it took. Wait, do they still do that? Okay, they changed it in the recent version. So by the way, this entire project is still very ongoing. So if you guys are interested, you can like actually follow it, because like I think like they have been just constantly been updating it over and over again. Livebook 3.0 came out yesterday. Was it yesterday? So yeah, they have a like sweet website that just happened like 2 days ago. Yeah, this presentation came out like yeah, around like 4 days ago. So it was very new. So right, you can now run it on the cloud. A lot of fun things. Yeah. So where is it? Oh yeah. So finally, after you created your training, you can test it out. Let's test it out. Let's pick a random image. Right. So this is. I'm gonna pick like something else. Wait. You know what? Is this 5? I can't tell. You know what? I'm just gonna check. Is it 5? It's 5. Right. I'm gonna pick something else. It is more distinctively a tree, right? So okay, by the way, one thing that I really truly like cannot like continue, because there's so many things that I keep forgetting about what Livebook does, is that you see this tail over here. The moment you change something on the top, right, you will almost never know what is happening at the bottom for like Jupyter Notebooks. So it actually tells you very nicely that, oh, by the way, this is stale by now, so you might want to rerun it. So you can rerun it, and it can give you the new answer for it, which is like 3, which is correct. Right, so I honestly have nothing else to share except for maybe like this entire thing, which is like where is it? I think I created like a long time ago. What's it called? Crap. Exxon. Yeah, there you go. So if you guys are interested, I created a giant README for the installation of this entire thing, because it does take a while for like Windows user to install it, because like it requires like WSL and like stuff. So it's running on WSL right now. Right, so it's running on Ubuntu. Yeah. So yeah, I don't think I have anything else to share. I'm just gonna send it to the thing. I'm gonna send it to the chat. Any questions?